Welcome back to another stream, everybody. Right, so a quick recap before we continue where we left off yesterday. What are we doing? We're making pick and place machine software. There's two parts to pick and place machine software. One, machine operations, where you move the head around and you pick things up and you put them down and all that kind of stuff. But we're not doing that. We're looking at the other part of it, which is preparing all of the information that a pick and place machine needs to actually do its job. Such as taking the EDA design files and working out exactly which components you need, where they are on the panel and all this kind of thing. So we've got our panels like this and we've got to work out where all the components go on each one and what the coordinates are and all this kind of thing. And in order to do that, we're writing a GUI tool which allows us to work with this. Work with this. Yeah, so let's bring up the GUI tool in question. Okay. Resize it, and here we are. So this is what we're working on. So what we're looking at here is a project over on the left hand side and the definition of a PCB on the right hand side, and we've also got a little Gerber viewer window over here, which admittedly is behind my head and you can't see it very easily. Let's pull it up here. Look, now you can see it. There we go. So we've got this, right? And over on the left hand side we've got a list of placements. Now if you've got a panel of say 6 of these defined like this, let me just bring that up there. You need to know the coordinates for where the component is on the first one and then where it goes on the second one as well, because you've got to instruct the machine to move a certain distance so that it can put the component in the right place. But your EDA tool only exports the information for one of these, and when you're making a panel, you might have multiple different designs on the panel. And when you're doing a pick and place machine job, you might actually have more than one PCB in the machine, which can be the case if your machine is you and your desk and you're placing components manually. So the software is supposed to work to help people do manual assembly as well as with pick and place machines. So we've got definition of a panel and we've got a list of parts on the left hand side here. So if we order it by a reference designator, we can see that we've got C1 listed 6 times, one for each of the positions on the panel. Okay. And then a little bit further over here on the right hand side, we've got some coordinates, and this is where the coordinates are for each of those C1 instances on the individual units on the panel. Right. So the goal of today's stream, and we might get there fairly quickly, I don't know, we'll see. The goal of today's stream is that when you click a row over here, it focuses the appropriate Gerber viewer onto the center of the component, for example, that one. That's all we're trying to do. You think, oh, that sounds easy. Yeah, right. There was 4 hours of work that went into doing some of this yesterday. Right, so yesterday we built this little thing up here which allows us to enter coordinates such as 0, 0 and then press go to, and that takes us to the origin, and the origin is denoted by this blue crosshair. So if you press go to, it aligns the crosshair up with a white crosshair which is the center of the view. Right. So if we say, I don't know, 20 by 15 and press go to, it takes us to this part over here. So if we were to say on the first one of these that's on the top, right, let's have a look. 43 by 40.55. Oh, that's weird. and press go to. Oh, we're looking at the wrong one. Well, I assume we're looking at the wrong one. Hold on a second. Yeah, wait a second. Oh, no. It's because the coordinates on the left-hand side have also got the definitions of the panel rails. So when we define a panel, we've got panel rails, which is sort of this area on the left here, and then we've got a gap here, so it's out by those coordinates. So what we're really interested in doing for this particular case is looking at the coordinate of as it is in the EDA design, but with the offset to the EDA design applied. Yeah. So anyway, it would work if we type the right number in. But what we want to do is make this happen automatically. Right. So yesterday we added this little tool window thing up here and that functionality to do that. And we also fixed a problem with the data tables so that when you click one of these things, it gives you information about the one that you clicked. And we also made it send a message from the project tab all the way back up to the main application tab, or main application window rather, and then down to the actual individual PCB, because the project doesn't know anything about the PCB tab. They're completely independent bits of code, right? So the only way to get one to talk to the other is to send a message up to the app and then have that send it back down to the right tab. So we did that, and down here we can see that the PCB tab is printing out that debug message, right? So what we've got to do now, from within the PCB tab, right, and this is the PCB tab, but the PCB tab has tabs itself, right? It's got this one, it's got this one, it's got this one, it's got this one, and it's got this one. And these tabs belong to one of these. Hopefully that makes sense. So the next thing we've got to do is find the appropriate tab for the message and send the message to the tab. So for our situation that we've got at the moment, where we clicked on something and it printed out this, we've got the file which was used to locate the correct application tab, the PCB tab, and we've got an object path, which is fine, we don't really need that. What we need is this bit of information. We've got the PCB side, which is the top, we've got the placement coordinates, and then we've got the unit coordinates. Right. So the placement coordinates are what you use when you're looking at the coordinates on a single design, and the unit coordinates are what you're looking at when you're trying to find the placement on a panel. Right. So there's two things we need to find. We need to find the panel window tab, yeah, and we need to find the design tab that corresponds to the design based on the object path. Yeah. All right. So let's try and do it. Let's do the design one first, because it's the more complicated of the two. Right. So if we've got a placement coordinate and we've got top, right, and we've also got the unit, this number here, which is unit number. Is it number? Yes, it's the unit number, because you've got indexes which are 0 based and numbers which are 1 based in the terminology of this app. So we've got the unit number of 1, right? And a PCB, when you define a PCB, right? This is how you define a PCB. You say, how many units are there? 6. Okay, great. What designs are on this PCB? Because you could have a PCB which could have all designs exactly the same, or you can have a PCB where the designs are different. Because sometimes you order one PCB and you build both parts of it at the same time. Maybe you've got like a stack sandwich PCB and everything about those is the same in terms of like the PCB stack up. So and you always build a top and a bottom together because they don't work without each other, right? So you design a panel which has got 2 different designs on it. So you need to list the designs and then map them to the units on the PCB and then give each of the units coordinates. Hopefully that makes sense. So here we can see I've got one design, this one, and it's mapped to 6 different units. Right. So we're dealing with that case today. Okay. So for this particular case, we always know it's the first design, but it might not always be. So we've got to write the code to make it work anyway. So let's have a go at that. So this information about the designs and the units is stored in a mapping. Yeah, and you get taffy weirdness. Gotta love taffy. There it goes. Righto. So we've got to look at that. So we've got our PCB. And we've got our core application. And our core application has got a set of views. And one of the views that you can ask the core application for is the PCB overview and also the PCB unit assignments. So the mapping is probably in one of these. So the PCB overview just has a file reference and a buffer, so it's not that one. The PCB unit assignments, however, has the unit assignments. Yeah. Wait a second. Oh, wait a second. I was looking at the wrong one. Okay, that was for the project. My bad. Hold on. Where's the PCB one? Here we are. The PCB has views and the project has views. Right. So the PCB overview has the mapping. Here. That's what we need. So we need to look at that. So from the context of our PCB, we need to find the design index for the unit from the map, which should be fairly easy. But do we have access to the overview now? So when a view comes back from the application, we get given a message, and that message is PCB UI command PCB view, and it contains the view, and the view is an enum that we saw, and then we've got handlers for each of the different enum variants, right? So when we get a PCB overview, we go to each of the tabs and say, here you go, have the latest information. And then we drop the overview that we received. So we don't actually have one to access at the moment because we've given it to the individual tabs. What we need is the mapping. We need the mapping in the place that we're writing the code. So we need to hold on to it somehow. We did something similar in the project. And we're going to do something similar here. We're going to go something like self dot update. I don't know. Should we keep the whole overview or just keep the mapping? Let's just keep the bit that we're interested in. I'm having second thoughts. Now, let's keep the whole overview. Let's just say self.pcb overview. Let's just do that. It's just going to be simpler. I don't think we need to get any more complicated with it. Yeah, let's do that. I'm just wondering where to keep this. I'll put it here with those ones, I think. Okay, so we've got that now. Great. So that means back where we were, we can now go self.pcb overview dot, well, yeah. If we've got one, then we can do something with it. Then what we need to do is get the unit map from it. And then I suppose what get with the object paths number. Yeah, so we need to futz around with the object path first. Oh, wait. PCB number and unit number. In order to do that, there's a method we call on the object path called PCB instance and unit. Right. So now we've got, well, we should have. Oh, and we're always going to have one, so we can unwrap it. There we go. That's better. So we've got a number here. Let's just check in the unit map to see whether this uses indexes or numbers. So this uses an index because we've got types that say index in them. So we need to convert this by subtracting 1 from them. And this seems to be a common pattern, so I might add some extra methods to the object path to get the indexes instead of the numbers, which might be useful. So we've got a PCB index, but we don't care about the PCB index because we're already in the right PCB tab. We do care about the unit index. So the unit map has got a PCB unit index, which is a U16. Right. So we can do that. Yeah. So now we've got a design index. Yay. Right. So now that we've got a design index, we can look for a tab that's got design Gerbers in it for this particular design index. Okay. So I think we can go something like self.pcb tabs lock unwrap. And then we can perhaps use something to find a tab. Okay, so in here, meh is a PCB tab kind. Now, the PCB tab kind can be either an Explorer tab, Configuration tab, a Gerber tab, or a Panel tab. We're looking for Gerber viewer tabs. Candidate tab. Right, I'm going to do this a simple way first and then refactor it later. So we're only interested in the Gerber ones. So here we go, false. Right, but we're only interested in the Gerber viewer tab if it's got the right design index. So the Gerber viewer tab has instance arguments, which has got a mode and a PCB side. Yeah. Well, yeah. Oh, Gerber viewer mode has got a. Yes, it is there. That's what we're looking for. So we're looking for a tab that's got a Gerber viewer mode of design with a design index of the design index that we're interested in. Okay. Okay. And I suppose we can go if matches Gerber viewer tab design index. Oh, look, the autocomplete might work there. Is that right? Matches. Oh, we've got a nested match thing. Fantastic. That probably is about right, isn't it? We check to see whether the design index is the one that we're looking for. Let's rename this though to candidate index. So that it's clear that we're actually doing a search here. Problem now is that no. Autocomplete fail. Gerber viewer tab has args. Autocomplete fail. Args mode. No, it's just wrong. Let's do it properly. Args mode. The thing that we're interested in was args mode, Gerber viewer mode of design. With a candidate index. Viewer mode, there we go, right, but only if this candidate index is the same as the design index that we're actually trying to find. what's the problem here? No. My ID does weird things sometimes. Most of the time it doesn't. But sometimes it does. Let's just say true here. So now we've got an optional tab key. This needs to be a reference here. We've got a tab key. Let's just see. Let's see if this works to start with. Right. Because we want to send a message to the tab, but we've got a tab key. So we might need a different method. Right, we need PCB overview none to be initialized, keeping the same order. That needs to use a reference. Yeah, that's okay. There's just two matches. There's two nested matches hiding there, basically, is what it's telling us. We'll ignore that for the moment, though. Right. So, the idea is that I've got two tabs over here, three tabs, and think about this. When we click on a placement, we should get three messages, one for each tab. But wait a second, we're only getting at one, aren't we? Because we find the first one. Okay, well, or none at all. Oh, we broke it. Oh dear. Well, I wasn't expecting that. What happened there? Oh, I bet I know why. I bet it's a locking issue. Have we already... Oh yeah, look, we already locked the tabs here. We don't need this. That's what the problem is. Okay. Everything's fine. So it basically just stuck on that, waiting for the lock to be released, which is never going to happen because we're in the same block of code that locked it. Placements. Click. So we've got a tab key printed out here. Look, there it is. Tab 4. Yay. So something worked. We found a tab. That was good. But we need to find more than one tab. So this find tab thing isn't really the right thing to do. But, you know, this bit is. This bit isn't. Yeah. What else can we do with tabs? Tabs dot. Oh, I think we've got a filter map. Yes. We can do that. Or we've got a with tab mut. That might be better because we want to send it a message. And this one lets us filter it. But we don't really want to map it to anything. We just want to like send a message to it. Let's go with tab mut instead. But the problem here is that it wants a tab key. So maybe maybe we need to build a list of tabs first, which gives us the tab key, and then we call with tab mut on each of the keys that we found. Alright, let's do that. So filter map takes a function which takes a tab key and a tab kind, which is similar to this but not exactly. So let's say we want a list of tab keys and we want to collect after this. And this is going to be a tuple of these two things, right? So here we want to store the tab key, I suppose. Oh, we return some here and none here because it's a filter, right? Let me just look at filter map. Oh, it's already doing the collection for us. It doesn't actually need. We don't actually need this. Right. So now we've got a vector of tab keys. Great. So now, for each tab, we can send it a message. With tab mut, that's what we wanted, isn't it? With tab mut takes a tab key and a closure. Now finally, we've got a tab that we can send a message. Annoyingly, we have to do this match thing again. Oh yeah, PCB tab kind. Okay, we have to deconstruct it. No, it's like this, isn't it? I forget the syntax sometimes. Right, so now we've got a tab that we can futz around with. And somehow we need to... somehow we need to access the tab from the list of tabs. Ah, that's in self, isn't it? Self dot. No, wait a second. I'm getting confused now. What do we do with these things? Yeah. Yeah. You see, we've got a tab, but all it's got in it is args, right? What we're interested in is the tab UI, which contains the component, and that's what we need to send a message to. I can't remember where I stored these. Let me refresh my memory. Somewhere, this. Go over your tab UIs. This is in PCB UI state. Right. That's what we're interested in. And to get one of those, we need the args from the tab. Right, we're getting in there. We're getting there. We're getting there. The PCB UI state is held in the PCB module along with the tabs. Right. Okay. So back where we were, we've got the args. We can do that if we wanted to, but we don't need to. Let's go Gerber viewer UI is self dot. We need to unlock this first. Right, we need to get that. And then once we've got one of those, I'm just adjusting my keyboard so it doesn't wobble as much. There we go. So instead of going to self, we now go to state. And then we can get the Gerber viewer UIs. And we can call get and use a reference to the tabs args. Right. And this gives us an option back. Can we just call unwrap on this? I can't answer that question at the moment, so I'm going to be cautious and use the if. Right, so Gerber view UI. Right, so now finally we can go to component and send it a message. And this component takes these messages. Oops. Stop it, IDE. And we're going to call locate component, which we don't have yet. And yeah, it's got the right things in it, which is good. Now, except that it doesn't need the unit coordinate because it's for a design, but should this be a different message? Because we've got a couple of options here. We could have a generic locate component message which takes both types of coordinates, or we could have two separate messages and then have a bunch of logic. Let's go with separate messages. Locate design component, and then the other one will be locate panel component, right? And then when the message is received, if the mode of the viewer is not panel, then it can ignore the panel messages, and if the mode is not a design, then it can ignore the design messages, and if it is the right type, then it can handle it accordingly. But is that just the same as just having one generic message and doing it anyway? Probably is, really. Let's just go locate component. Thus. Yeah, We'll do that. Yeah. I think that makes sense. So, oops, daisy. So we'll just reformat this alignment and fix the imports, of which there are many. Right. Yeah, we can print out the tab key in this. No, I'm just going to delete that. Let's turn this into a trace message. Why doesn't it think this tabs is used anymore? It's a bit weird. Because it's used there. That's weird. My ID is having a little brain fart. Lifetime may not live long enough. Right. So we clone the tab key. And here we need a reference to it. Right, so now we're in the Gerber Viewer tab. We are getting there now. So now we need to handle the locate component. And there's no action that gets returned. So where we had this go to clicked, we go we need to forward a message to the Gerber Viewer component, because the Gerber Viewer component is just a thing which you can render anywhere, but the Gerber Viewer tab is just a tab which has some controls on it and a component that renders Gerbers. And it's that component that we need to send a message to, because it's what controls the coordinates. Right. So now we need to look at our current mode to determine which set of coordinates to forward, I think is what we need to do. Let's go match self dot Gerber UI. We need the args. We don't have the args here. Just wait a second. Does the context have the args? Context. Your view tab context. It doesn't have anything at the moment. Maybe that's where the args need to be. Let's do that. Args. Right. And the reason we need that in here is that when the update message is called, no, not that one. From here. I can't remember where it is. Context default is true, doesn't have one there. Let me find it. This. Okay. This thing. No. Wait, where is it? My brain hurts. I'm just getting lost in the sea of tabs and update and UI methods. There's too many, and I can't remember where they all are. Oh, it's probably in here. No, it's not this. No. Well, I'm trying to find the place that builds the context. I suppose when I try and compile it now, it'll tell me where it is because it won't be initialized correctly. So here we can go underscore context.args. I'll come back to it in a moment. But what we're trying to do is that. Right. But we've got to build the context somewhere, and I can't remember where it is that we're supposed to build the context. But hopefully there should be a compiler error telling us that we've not built the context properly. If there's not, I'm going to be slightly surprised. Oh, it's because there's a default implementation for it. Damn it. So it's not telling us where it is. If I take this default off here, then it'll tell us. There it is. Why couldn't I find this earlier? Gerber viewer tab. That's one place, but where's the other place? Here it is. Here it is. So it was hiding in the switch statement in the PCB module itself, where we need to call update on the appropriate tab. Right. So here we've got the args, which is this, right? So we can build a context. But this needs to be public. And now it's going to complain that it's moved. But we can not clone it again, hopefully, by doing that. Yeah. So now we've built the context properly. But there's another place where we need to build the same context. Now the question is, do we have that information here? So we're in the Gerber viewer tab, and the Gerber viewer tab has args, so we can build it, which is good. Do I want to get into a world of lifetimes? Not really. I was thinking about making args a reference to the args rather than cloning it, but you know, it's only a very small thing anyway. But you know, it's an allocation that is possibly unnecessary. Anyway, right. So now back here, we will actually have the arguments that we need in order to let us determine which set of coordinates, either the placement coordinates or the unit coordinates, that we need. So from this we want coordinates. Right. Somehow. We'll come back to that though. But what we want to do is this. We want to send those coordinates to the Gerber Viewer UI component via a command. So this needs to return a tuple of x and y. So if it's a panel, then we take the unit coordinate x and y. If it's a design, and we don't care about the design index because we already know that the design is correct for us, then we take the placement coordinates. Which should be right. Yeah. And then we can go coordinates. Well, I suppose we can go like that. Right, so locate view wants an F64, but what we've got is decimals. I suppose we can go default for an F64. Oh, default. Okay. Does it work? PCB side. We haven't used it yet. We might need to look at that a little bit more. Okay. Something happens. I don't know if it's right or not. I think it might be right. Let's go to the. What are we looking at here? This is the top, I think. Let's close these so that we know what we're looking at. Okay, we're looking at the top over here, and we're going to look at the list of placements for the top over here. And when I click one of these, it should go to a part. Oh, that's magical. Oh, brilliant. That's fantastic. Cool. Yeah, that works pretty damn great. Look at that. Amazing. 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 So, this is good. We did it. Finally. You have no idea how long it's taken to get to this point. Like, we couldn't even display Gerbers a couple of months ago. And now we've got Gerbers. Look, we've got Gerbers and we can zoom in and out and everything. That was a mission in itself, just getting that. Full Rust implementation of a Gerber viewer. And now we can locate components on it. That's excellent. Woohoo! Alright. Let's just see if it works to the bottom. And we're going to go bottom. But we've got some fixing to do still. Let's not get, too excited. Yeah. Yeah. The problem is when you look at the bottom, we've got offsets and mirroring to deal with, right? So what's happening now is that when I click one of these components, let's just leave the zoom level here, you can see it is moving around, but the coordinate is not mirrored. Right, so the question is, Do we fix the coordinate, or do we fix the display of the Gerbers? Because when we're displaying the bottom, let's have a look at the code and think about it for a moment. I should probably do a commit at this point. Yeah, let's do a quick commit. Let's reformat everything. There we go. Except that it's left behind some stuff because there's bugs in it. What's it complaining about? It's complaining about PCB mod.rs. This one, line 880 something. What? 888. If anyone's played Fruit Machines, I would have won a prize today. With that number, 888. Bar. Where? Oh yeah, look, there's a space there. Like, why doesn't it delete that? Okay, run it again. And it's complaining about this as well. Why? Like, why didn't Rust format fix that? You know, every time I get these, I submit bug reports, but it happens so frequently. It's just like, I'm tired of submitting bug reports all the time. But I'm also tired of fixing the problems, so it's just like the worst of both worlds. Anyway, that bug reporting can wait another day. Maybe I'll... No. Does it work now without any errors? Yes. Okay, good. Quick review of what we did. We stored PCB overview when we receive it, and we added arguments to the context for the update and UI messages, and we did this to-do thing. Oh, I don't know why I tried to delete it from there. And we send messages to the appropriate tabs. We find the tabs and then send messages to them. Yeah, okay, now that was all good. All right. And then in the Gerber view, oh wait, was that a comment in that bit of code I saw there? What was that? I'll delete that in another commit. And then in the Gerber view tab itself, we forward the message basically. Locate component to locate view. Because the Gerber viewer itself doesn't know anything about components. Technically it could. Technically it could, because Gerber files define component attributes. But the problem is that most of the Gerber export tools, most of the tools that you use to export Gerber files, don't include that information. KiCad does, in like version 9 or version 8 or version 9, but most of the tools don't. So we can't rely on it being available. But if we were to tell the Gerber viewer UI to locate a component instead of locate view, and we gave it the reference designator, then if it had the attributes for that component, it could highlight the component's courtyard and make it flash. That'd be a nice to have in version 5, wouldn't it? Not happening today though. Right, so what is the commit message here? We are locate center the Gerber view on the placement coordinates. Something like that. When a locate, well, hold on. EIIE, one of those two things. Yeah, so we did that, but it needs a bit more work. Okay, so I've lost the code that we were working on now. This bit, right? Let's close all the other tabs for now. Yeah. So the Gerber view UI component is what we need to have a quick look at. So we've got this component, right, which is basically just like a square that you can render Gerber files into, essentially, and that you can also drag and pan around, right? And this uses the Gerber viewer crate that I created in order to do that. And it calls paint layer, right? And one of the arguments to paint layer is a transform. Right, and this transform is based on the layer itself and also the states transform. Now the states transform has things like rotation, mirroring, origin, offset, and scale on it, right? And I believe somewhere we go, if the PCB side is the bottom, then turn mirroring on for that layer. Now the reason we do that is that when you're viewing, wait a second, hold on. Yeah, when you're viewing that layer, you want to be able to see it, and you want the text flipped so that it makes sense. But in the context of pick and place, you do want to do that because it's like the physical thing that we want to actually refer to, and that is flipped, and the text is legible in the right way around, and the coordinates do need to be mirrored. Yeah. Right. But should we be adding an offset? Should we be adding an offset such that all the coordinates get moved over into the positive range again? Because the EDA export pick and place machine coordinates, yeah, they normally have to be positive, because the origin of a pick and place machine is normally sort of like the bottom left on the machine. It need not be, but it usually is. That's how you're supposed to set them up, at least with the one behind me here. That's how it works. So all the coordinates need to be positive. So what we've got is positive coordinates for the unit positions, which is correct, and then we've got negative coordinates for the Gerber because we mirrored everything. What do we do? What do we do? Let me refresh my memory. So we've got designs, fine. But when we click this one, we're seeing the top and the bottom. Right? And there's no mirroring going on this at all. Let me just click these to make sure it works. See, it does work. So we're looking at the list of parts for the bottom here. Right? It says side bottom. And when we click on these, it highlights parts that are on the bottom. And we can see our layers tab, layers tool window here shows that we've got top and bottom layers here, right? So yeah, right. Image transforms versus Gerber transforms. Right. So, if you remember from yesterday, which you might not do unless you caught the stream, in the Gerber specification, we looked at these. I said I implemented these recently. Mirror image, and there was rotate as well, right? So in order to implement these, let's go to the Gerber Viewer crate. Gerber Viewer, that one, in a new window, right? Renderer. Somewhere. Yeah. It asks the layer for its image transform. Because in the Gerber specification, which is what it is, it seems that the original intent behind these commands, which are deprecated, is to get the image and mirror it or rotate it as a whole, right? But when they originally designed the specification, they distinguished between coordinate data and non-coordinate data. And what they said is that step and repeat distances are not coordinate data. But if you're using step and repeat internally on a single unit, right, as opposed to repeat a unit, right, then you want to mirror the individual unit and keep your step and repeat distances such that each time you repeat it, it's still mirrored, right? But you could use step and repeat internally in one of these things and not use step and repeat to do panelization, right? So because of that, mirroring image is kind of broken, and they say don't use it. Yeah, and now there's an alternate for step and repeat, which is implemented. So it seems like the original intent for mirroring, for the mirror image command and rotate, is to rotate the whole thing. But the step and repeat just threw a spanner in the works, and it all just went pear-shaped. They didn't think about it hard enough. So the original intent of this is to mirror the whole thing. That only works if you're talking about it at a design level, and not a panel level. And the way that I've implemented it is that I do treat everything that gets rendered, including all the things that get rendered by step and repeat, as part of the image. And then when I apply a mirror image, I mirror everything, including everything that was step and repeat, because that seems to make more sense to me. Yeah, so that's how I implemented the image transforms in the Gerber view itself, which is useful for us today, because I suppose what we could do is, instead of adding a Gerber command to the file, which we're not going to do, yeah, we're definitely not going to do that, because we don't want to touch the source files for the Gerbers that we're trying to render. What we could do is add another argument here. I'm not sure about this. For the image transform. Oh dear. And then combine that with the render transform, the original layer image transform, and then we've got a sort of. Maybe we don't need to. Maybe this one does it for us. We could do it with this one for us. No, we should be able to do it with this one. Wait a second. I might be going mad. But the coordinates. You see, one of them changes the coordinates and the other one doesn't. I mean, they both sort of change the coordinates, but at the same time they don't. Okay. Let's see what we can do. Let's see what we can do. So let's look at where we set up the transform. That's the layer view state, but that's not what we're interested in. So each layer can be independently shuffled around upon the other ones and rotated, right, when you're displaying multiple layers, but we don't use that functionality in this at the moment. Because we can't offset things without knowing how much we should offset things by, and the Gerber viewer is dumb and it doesn't know anything about that. Maybe maybe we should give it some more information in the form of the args. So what I'm thinking, it's pretty involved, this problem. So the reason I'm thinking that, like, you can look at design like this and everything's fine, right? But the origin of this design is how it appears in the design files, which which makes sense, I suppose, because we could give it some args to offset that, to bring this back to where it would be for the PnP machine. Should we really be? I don't think we should futz around with that though, because you want to look at your PCB, you want to look at the designs so that you can work out what the offset is, for instance. So like, I add the Gerbers to this, but I don't know what the design offset was. But if I click on this, you know, I can have a tool window that shows me what the offset is of where the cursor is, so that I can work out what this distance is here, you know, 10, 10. I don't want to break the ability to do that by offsetting it with the information that we've already got in here, because we want to be able to calculate it from the UI. So I don't want to do that. Maybe we should just mirror the coordinate. Maybe that is the simplest thing to do here. I think it probably is, otherwise we're in the depths of like more transforms. I don't really want to go down that path. I don't know, I'm not sure. I'm still not sure. Not sure. Did this work? But we didn't check this yet. No, we didn't do this bit yet. Let's do the simplest thing to start with until we find that it doesn't work. Because then we haven't wasted too much time. So let's try that. So if the PCB side is the bottom, then we just invert it on the x-axis, because that's what we did here. Though I suppose what should happen is that the Gerber viewer UI itself should do that, because only it knows how it mirrored things. Yes. Okay, so we'll try that. So if self dot args PCB side, I suppose we go matches some PCB side bottom, then x is minus x. Oh. Let's see, man, that might work. That's how you do mirroring, right? All right, so we've got the top and we've got the bottom. So we're interested in the bottom. So let's find a component for the bottom and click it. It works. Now, the fact that the origin is to the right, I don't know if that's I don't think that's a real problem, really. Because we can just have the UI show that it's mirrored if we wanted to. It's probably okay. I mean, it works, right? Look. And let's, for fun, pull this down here and zoom in a bit on this one. So now we've got the top up here and the bottom down here. And then if we go on the entire list of placements, we can step through these things. Oh, Houston, we have a problem. Yeah, they're both updating where really only one of them needs to update. Okay, well, I suppose we fix that next too. So it should ignore it if it's not for the right side, I think. Locate view, but locate view doesn't know to ignore it. So where we send the message is probably wrong. Here we've got PCB side. Gerber view of tabs. We've got the arguments here, I think. This context is this, and this has args. Yeah. So I suppose we can go if PCB side. What do we do? We've got args. What's args in here again? Args, we've got this, and we've got the PCB side, which is an option. So if we've got a PCB side and the side is not the right one, then we ignore it. So I suppose love the autocomplete there, that was good. If there's some PCB side and it's for the other side, then we return it. And this is wrong. It's just going to match to itself. Okay, the autocomplete failed, but it was close. Then we ignore the message. Let's see if that works. And then we can do the panel case. No, we did that already. Oh look, it works now. Amazing. I'm thinking what would be nice would be a view that switches between top and bottom. But I don't know. That works. That's pretty cool. Do you know it'd be really nice if it animated towards it? Yeah. So if it updated the coordinate over time and like bounced to it, that'd be cool. Maybe I'll do that off stream. Could be interesting. A fun little thing to do. Just so you can see sort of like where the direction is from what you were just currently looking at. So for instance, you know, like when you're going through these pads. Damn, there's a lot of components on these things. Oh, we don't have oh yeah, here they are, SPs, for instance. Solder pads. Yeah, it would be nice. Yeah, I might do that. Cool. Yeah. Yeah, we like that. Okay, so that seems to work. Let's do a commit. So what did we do? We ignored messages for the wrong side. And we did mirroring. Yeah. Well, this thing really is a bug fix to that last commit, so we're going to amend that. And this thing is ignore locate component. Ignore inapplicable component messages. Yeah. Okay, we did that. Right, so what was going on with the panel? Because we've got these ones which we don't really care about, but what I care about is locating the components on this. Right, it doesn't do anything. Yeah. So we need to make that work. So the PCB tab received a locate component message. Right. But we're only sending messages to the design ones if the design index matches. Right. So the other thing we need to do is if it's a Gerber viewer tab and it matches the other thing, then do that as well. Yeah. Let's repeat that here. Change this to panel and delete this from here. I think that should do it. I kind of want to combine these into a single match statement now. Oh. Which isn't the easiest thing to do in the world. Something like this. And then we've got this here. We need a bracket here and a comma. I don't think we need a comma, but Gerber viewer tab. My IDE's coming up with some errors here. It's a bit weird. Got one too many brackets there. That should do it. So we're saying if it's a design where the design matches, or it's a panel, then clone the key and then send the same message to all of the tabs corresponding to the keys that we found. Yeah. We're not currently using this. We don't need to use it. Oh, I broke that then. So, does it work? That's the question. Panel. Placements. No. What happened there? What? What was happening? We've got placement coordinates, and then we've got unit coordinates. I bet I know what's going on. It's not obvious what's going on here, but I think I know what the problem is. Units. I was thinking about units yesterday, and that they're going to come and bite me. Today's the day that they're biting. Let's just quickly check this. So I'm going to find the Gerber files for this design. Give me a moment. H7 Neo, manufacturing files. These ones. Right, so we've got this BS file, KO and TS, right? Right. Board outline is BO. You see that? You see that? That's the problem. So I've designed my board in millimeters. They've taken my Gerber files, created a panel, And when they created it, they converted all the coordinates to inches. So what's happening is that it's going to like 10, 40 something inches away from the origin instead of 40 millimeters away from the origin. And that's the problem. Yeah. I suppose if we zoom out far enough, we should be able to see this. Right? Yeah, look. See? That's funny. So I guess I need to add support for converting the coordinates from inches to millimeters. The other way around. Millimeters to inches. Or just the coordinates from the current user representation of them. Yeah. Right. My pick and place machine behind me over here, this thing, it only works in millimeters. That's it. Right? So because of that, all the CSV files and job files and everything like that you give it, all the coordinates are always in millimeters, always. Everything about the machine is in millimeters, which is good, because millimeters are sane. Inches are insane. And I'm allowed to say that because I'm British and it's an imperial measurement. But I don't live in England anymore, so, you know, I never liked inches. Didn't like fractions at school either. Right. So my machine is millimeters only. So because of that, most of the work that I've been doing is only using millimeters. But unfortunately, the rest of the world uses other forms of measurement, and we have to deal with the heretics. Yeah. So we need to do that. But in principle it works. I mean, can we just hack something in real quick? What do you think? I suppose we could. In the Gerber viewer UI, I suppose if we said coordinates in millimeters, I suppose if we be specific about it, x, y coordinates in millimeters, right? Then the Gerber UI can go, well, what is the unit of the files that I'm displaying? And it's even more of a problem if the Gerber viewer is currently displaying multiple layers, which it is, because each of the individual files could technically be in different coordinate, use different units. Right, so I don't know, maybe the people that make the stencils saved the file in millimeters, and the people that made the panel put it in inches. It's possible. So internally, really, all of the coordinates that the Gerber viewer wants to ever deal with should be in one unit, really. And then there should be conversions to that preferred unit, millimeters. Yeah. So this is painful. This is painful. Oh my god. So when we're adding layers, we add a layer, right? But the Gerber layer doesn't have any information whatsoever about what unit it's in. This isn't a thing that I can do quickly. And if we read a file, you know, when we're parsing it, at this point we've got a Gerber doc and a set of commands. And one of the commands has the information about the units in it. Oh dear. Oh no. Oh no. Oh dear. We have a vector of commands when we do add layer though. Hold on. Yeah, I suppose. Like, panel preview has it, we're okay. We've got information there about the units. So I've basically got a set of commands that I need to search through to find the units. Yeah. It requires some thought, this does. Because, yeah, what should you do in the case where you've got multiple different formats in your list of Gerber files that you want to display? Let's we've got a Gerber state add layer, right? Build layer from commands. Is this called twice? It's called an add layer, and it's called in build Gerber layer from file. Okay, and the Gerber doc has units, right? It's optional, and so I suppose I suppose we could add a function to get the units from the list of commands. But when you add a layer, do we need to even store it individually with each layer? Like, if you've just got a set of coordinates and you've got a bunch of layers and they're all different units, and you want to locate the view of all of the layers, you don't need to know about all of the layers units. How do you do the conversion? It won't matter, will it? Because the units represent a distance from an origin, and that distance from the origin will be... Yeah, no, it gets scaled up, doesn't it? Because the renderer doesn't do any scaling of the layers based on the unit. Should it? That's the question. Probably not. Yeah. I think I'm going to have to do a bit of experimentation off stream to work out what I actually want to do here, because there's quite a few different choices I can make, and I don't know which one is the right one at this point in time. Yeah, some experimentation. So, I think we're going to call it here for today. So let's have a quick recap as to what we finally managed to achieve, which is where you've got your list of placements and your top and bottom PCB designs. We can now clicky locatey things on the views. That's what we managed to do. This is excellent. Let me just check. Let me check to see if I've got some manufacturing files for another project. Just to see. No, it's the same company that made this for me as well, so this is probably going to be in inches too. Yeah, it is. Nuts. It's quite interesting. I'm looking through another project now just to see what happened with. Yeah, no, I'm just going to leave it. I'm not opening that can of worms. No. So yeah. So this is what we managed to achieve today, which is excellent. That's really great. Next up, I think what I want to do is to pass the rotation information through to the view, and then where we've got this center view mark, right, is put some kind of marker there which shows like the rotation direction. Because this all needs to match up. Yeah. So the rotation information that we've got is this number here in this column. So I think I'll probably have a go at that at some point as well. That's going to be a little bit tricky. Because working out where to draw. Well, no, I suppose you always draw it in the middle of the screen, but then what? Yeah, no, you don't. I mean, you could always draw it in the middle of the screen, and then if you move it, it disappears. But we also, it feels like we need like an overlay on top of the Gerber files, where we show the pick and place nozzle rotation. Yeah, might have got that at some point as well. Alright, so we're going to leave it there. So, hopefully, this was interesting. If you liked it, then press the little like button down the bottom. Subscribe for the next one. And yeah, we'll see you then. So, just remember, folks, it's only software, How hard can it be? We'll find out in the next one. See ya!